Hi, and welcome to the Entity Framework Community Standup. We're back again with Jeremy, as always, and with David, who's going to talk to us in a little while about Azure SQL and everything cool around that. So that's going to be super interesting. Without further ado, let's start with our usual state of unicorn. Let me do that. So it's been a fairly quiet couple of weeks, actually. We've got a lot going on in the background, but not too kind of publicly visible. But I'll go through a few things anyway. So EF Core 6.0 Preview 3 is coming out any day now. It doesn't. We have quite a few bug fixes and tiny kind of tweaks to functionality in there, but there's nothing really cool or new to look at in Preview 3. Hopefully, Preview 4 will be better. We're working a lot on stuff under the covers, which I will go into now. So the first PR for SQL Server temporal tables, Maurici on the team has been working on that, and he has the first PR out on that. There's still a lot of work to be done, but it's looking like it's coming together quite nicely. Doing some work right now on the migration side of it. Also, after doing a lot of work in terms of runtime model optimization of various things, Andrea is now actually implementing the compiled model. So that's kind of exciting. Hopefully, that will give us better startup times, better performance, better memory usage. Lots of bug fixes going in. I spent a bunch of time over the last couple of weeks just fixing bugs. So we're doing that. That's always great to see. And that's about all that we're doing right now. It doesn't seem like much, but I'm sure you're all aware sometimes a lot of the work goes on behind the scenes. So, as always, we have a doc of the week to tie in with the Azure SQL. I'm going to show the connection resiliency doc. So this is this is on our documentation. Go to the EF docs. It's this link. We have a link to it on GitHub and search for it. It's easy to find. Under miscellaneous, we have a few sections, and one of them is connection resiliency. Now, so when you're using EF Core against a database that might have connectivity issues, which can often be the case when you're using cloud services, then EF has the ability to retry connections, retry operations. We call it connection resiliency. It's a little bit confusing sometimes because you turn it on by enable retry on failure, which doesn't really tie too much to connection resiliency, but that's how you turn it on. And that will cause us then, if we get a transient error back from SQL Azure or from any other database, this will work with other database systems as well, then EF Core will retry that. And that includes restarting the transaction if EF Core started a transaction for you and redoing the transaction. And also, if you're doing a query and we get back half the results and then it breaks, then EF Core will also retry that query. In order to do that, it switches on buffering internally. So there is a downside to it that you end up buffering instead of streaming. For most practical purposes, that doesn't make very much difference. And our recommendation is if you're using Azure or any kind of remote database, really, it's a good idea to switch on execution strategies. You can configure the execution strategies, retries and stuff, retries and the number of times and the back-off delay. I think it has kind of an exponential back-off with 5 retries or something by default. I may be wrong on that, but it's something like that. You can also create custom ones. If you're using your own transactions, it gets a bit more complex because you'll probably have to manage restarting that transaction since we don't know what you've done in it before we start doing stuff. So there's some documentations on how to use that with transactions in here as well. And then there's a few like kind of corner cases. Transaction commits can sometimes fail in a way that is unknown. And there are various options on here on how to deal with that. Most people do almost nothing and it's fine. But if you do run into that, there's some good docs here on different ways to track it, to deal with it. So connection resiliency, again, another one of our doc pages. And with that, let's move on, I guess, to David. Do you want to introduce yourself and tell us what you're going to talk about?
Yeah, sure. Thank you, Arthur. So Davide Mauri from Italy, but actually living in Redmond since 5 years ago. And I'm a PM in the Azure SQL team. I'm specifically interested in making sure that Azure SQL is really, really the best place for developers to be. So doing a lot of work around that. And today what I want to discuss with you guys is some of the feature we already have in the engine. I think in the last year we did a great job packing a lot of stuff in the engine. We didn't do such a great job in telling it to the world that we have such greatness. As part of my job, I really want to make sure that we have enough let's call it again evangelization as we were doing in the past, but samples and discussion with guys like you, conferences. So super happy to be here. Absolutely.
Awesome. So I think you have some slides. So should we start with that and let's do and let's see where the discussion goes. And of course, everybody ask questions, preferably about what we're talking about. But any questions is fine, and we'll try and answer them as well.
Yeah, so again, since I'm really, and not only me, literally all our team is really focusing a lot on improving developers' life lately. We started to try to understand exactly what a modern developer wants or what a modern application is, and of course, this definition is very, very foggy. I would say it's not clear, right? But we found out that there are some recurring requirements or requests, like scale out. Ability to scale out is definitely like a given, right? So all modern application needs to be able to scale out. Resiliency and reliability is kind of something that, again, developer wants by definition, especially since you are in the cloud. And you kind of are used to have your application resilient and automatically restarting, all this kind of stuff. Another important thing we notice is that people want to be able to quickly improve and update and evolve their application. So using a very agile approach. And so definitely CI/CD is mandatory, right? So typically what I do, and I don't know if that happens to you, but I usually start a POC and I don't really care about, setting up Git or other stuff. I just, want my code to work. But as soon as I have like 10 lines that works, I immediately set up like my Git repository and start to push it, even if I set up a private repository, just in case.
Right. Absolutely. And as soon as you don't do that, that's when you say, "Oh man, I wish I could go back to that version I had yesterday." But
it's always too late.
Yeah.
Right. Yeah, because always I start to say, okay, let's see, if this idea I have in mind it works. But it's like, man, I'm not sure it's going to work. So no point if wasting in quote my time setting up a GitHub repo and stuff. Then it starts to work and say, okay, now I have to do it.
Yeah.
Yeah. But other stuff that we notice is that the integration with other services, it's even if you're not really, having in mind to do a microservice solution, integration with other services is mandatory, because at some point you need to, use that service and you want to be able to easily do that. Maintenance is like something that, what that is? Not sure. So ideally, there is no maintenance at all in developer's mind, right? And in general, you want to use the best technology to solve the specific problem. So in database world, it could be that you want to use a graph, you want to use a document, you want to use entity framework, something else. But ideally, you really want to have the complete freedom to do whatever you think it's the best for you. Absolutely. So with all those things in mind, what I started to put together is this slide deck that I think it's quite interesting, because Azure SQL, of course, is a general purpose database. So it's not like a specialized key value store or relational. But I say that, and I'm besides C#, I also like a lot Python, and from Python I took this sentence that basically the PEP directive says that Python comes batteries included, means that you already have everything within Python to do whatever you want, right? From JSON support to whatever you need. And I think that this applies very well to Azure SQL, because what we did in the last years was to try to build as much as possible into the engine. Even if the market was more going toward like a super specialized database, right? Because you have you have document database, you have key value store, you have graph database, you have cache that are hyper specialized, I would say. And I think those are great, of course, but they come with a challenge. If you have 4 databases, who do you think is the responsibility of making sure that integration goes well? Developers, right? And honestly, I don't know what you think about that, but I find integration quite boring as a task I have to do. I mean, it's not exciting. It's like moving data around for me.
Yeah, no, I mean, I think you're right on that. I definitely on the EF team, we recommend people use the right tool for the right job, but I think people assume that they need a document database for things that they don't actually necessarily need a document database, or that they need a key value store, or they need super high efficiency streaming or something like that. And it can be a lot easier just to do this stuff with SQL, basically, rather than trying to use those other specialized things.
Exactly. I mean, before joining Microsoft, I was in a startup and we were doing big data on wearables, right? So we were ingesting data from basically everything you can wear today, from shoes to socks to whatever. And we had SQL Server, we had Elastic, we had MongoDB or Cosmos. And man, the amount of work needed to keep all data in sync was incredible, literally incredible. And so unless you really are, big enough to have enough engineering resources to dedicate to that, the ability to have everything in one database, if that works well, of course, it really simplifies a lot. So that's why we started, for example, to add stuff like, for example, let's talk about that, high concurrency optimization. So in Azure SQL, we added the ability to have tables that doesn't have locking at all. So we have some tables called in-memory table that simply don't use locks, period. Now, it's been known in the past that Azure SQL Server in general, was not that scalable, exactly because you had to hold locks. And if you remember, there were all, debate, no lock, read committed, or read uncommitted, all this kind of discussion to make sure you can scale as much as possible. So we worked hard to implement something called multi-value concurrency control, which basically we don't acquire lock at all. And a single table can handle 1,000 and, and 100,000 concurrent transactions, simply because there is no locking at all. But still, it's completely ACID, so it's completely isolated, it's completely consistent, it's completely, have all the transaction properties. And what I think is beautiful is that table can be easily joined with a regular table. So maybe you don't need all the superpower every time for everything, as you were saying before. So you can literally choose and pick and choose where you want to use this feature. For example, we added go on.
So for the high concurrency optimizations, are those only available if you have a memory optimized table, or can you do those on a disk-based table as well?
So the highest optimization is when you have those in-memory tables. So when you create the table, you specify, as you said, memory optimized on. You can, in that case, you can even decide if you want to preserve the data or not, making the table actually really a cache. The same approach, of course, implemented differently, because in that case, we actually take lock. We can also use it on disk-based tables. In that case, what we do is basically still keep different version of the row. Basically, we write those in tempdb, and we allow you to access the specific row you should access based on your transaction context, which means that, again, by default, you don't have to wait for someone else to finish writing, for example. And this is by default what Azure SQL has, which is different compared to what you have on premises for just compatibility purposes. So right away on Azure SQL, you probably will experience less problems in concurrency, definitely.
We have a question from the chat.
Oh, interesting.
Whether it's locked to a single thread.
No. The table is still regular table by all means, so it can be accessed by multiple people in at the same time. The concept of thread in SQL is very complex because we even have what we call our internal operating system. In fact, you have a lot of views called OS something, a memory allocation, semaphores. We have everything, but is basically implemented. Actually, when you create a table and you specify memory optimize on, the table is actually rewritten as a structure in C and compiled and executed in memory. So it's super. Actually, there is a C compiler inside SQL Server or Azure SQL. So it's pretty interesting. And the same goes for storage procedure. So if you really, those tables are so fast that if you use a regular storage procedure, you will spend more time compiling or interpreting the storage procedure than actually accessing the table. So you can do something called native compilation. So that even the storage procedure are actually compiled into DLL and executed in memory. This is really super fast. So just to give you an idea, we had a document also available online where we can ingest 5 million rows per second on a very stressed IoT application.
Wow.
So that's pretty interesting. And this is exactly on the same database that you can just use every day. Just switch this feature on, and it's really amazing. And the beauty of the work we do behind the scene is that, let's say you also have advanced analytical processing needs, like you want to aggregate quickly, you want to quickly do some analytical query, which usually means aggregating over time, comparing one period to the previous period, and so on. So we have a column store support. And honestly, I think this is quite unique in the cloud database. You can have on the same table could be both a row store, so regular, perfectly fine when you want to have singleton lookups or access a few rows, but to the whole information that is retained in the row. Or on the same table, you can also have the column store, which means that will make your table super fast when you do things like aggregate by month, for example.
Excuse my ignorance, I am only a manager. What's the difference between a sparse column and using a column store? When would I use one over the other?
I have a slide that can help at least understanding exactly what a column store is. And let's see if I have it here.
I love the response, by the way. I've got a slide for that.
Yeah, but I have one that mixes things together already. Okay, no big deal. But this is still interesting to show, I would say. So this doesn't show how it works, so I will describe it to you. I thought I copied and pasted, but already I went to 32 slides, so I stopped adding stuff to this slide deck. But just to give you an idea, so the same table, in this case, the table is even using a graph. So this is a table that behaves like a graph, like edge and nodes, right? So we can also have that option in Azure SQL. So you can truly choose whichever model you want. Without an index, if you want to aggregate over these three tables, that have 1 million unique song, 1 million unique user, and 50 million likes on a 2-core machine, right? So very small. If you do an aggregation to understand who is the most influencing person, and you need to aggregate, for example, to understand how many people he influenced and those people also influenced, it will take 30 seconds, right? Without any index, because you have to scan, do the calculation, and all the stuff. With a regular index, so the classical clustered or non-clustered index, which basically every row is fully saved in the index, or at least, let's say, is saved in the table. And so you reason row by row, okay? It still takes 22 seconds. If we switch to a column store, where basically we save each column on its own, and given that its column is saved on its own, you can highly compress all the data contained in that column, because unless you have only unique numbers or unique values, it's very likely that values in a column repeats frequently. So we can compress hugely. And let's say you have 100 columns table, but you are only interested in 3 or 4. So we can only read those columns, and since we save the column on a kind of on a standalone basis, we don't have to also read the other column that we are not interested into. So we can go super fast, and so the same query goes from 30 seconds to 22 to 3 seconds.
Wow.
Now, what is the? Yeah, this is amazing, right? And this is on the same table. So I honestly think it's pretty unique in the database world, but I'm sure it's quite unique in the cloud database world, because as far as I know, there are no other database that provides on the same object table, in this case, support to column store, row store, and graph support, for example. So this is definitely unique. And
Oh, go ahead, finish.
Oh, just want to answer the sparse column. Sparse column is another technique. Let's say you have, 100 columns, right? You still want to save all the columns in the same place because you want to do a singleton lookup. So when you find that row, you want to read all the other columns. But you know that many columns will be empty. So you don't want to waste space saving even metadata for that column. So sparse means if the column is empty, we literally don't save it, which means easier for very wide table to handle a lot of columns. It's not a very typical use case. It's typically common in CMS or place where the user can add their column themselves, but the value in a specific column is very sparse. So yeah, as you can see, we have a lot of different techniques.
So I know numbers are hard, but at what point would your data size get to the place where you should start considering a column store versus just, not? I mean, the reason I'm asking this is because we often get customers coming in saying, hey, I want to use that. And then they don't actually have enough data, for example, to take the column, for example, to really make it worthwhile. And so while this is an awesome feature, you don't want to spend time and effort doing this if it's not going to get you. So what's kind of the level where you should start thinking about this thing?
Yeah, as you said, the really difficult saying number. So let me say that column store, of course, as an overhead is highly, highly, highly optimized for read. Now, we do some trick behind the scene to allow developer to write into the column store. But what we're actually doing is that we are presenting the same table, something that is actually two different objects. One is a column store, and the other part is a regular row store. We write and do the updates and deletes into the row store. And then when the row store becomes big enough, we automatically convert behind the scene when we merge it with the columnar part. Now, so this means that using a column store has some impact on write performance because they cost more, but you gain a lot in terms of reads. So if your workload is mainly reads and you have a decently big table, like some million of rows, but again, it depends how big are the row, how wide is your table, then definitely start to make sense. Now, I wouldn't use a column store for probably 10,000 rows. That's definitely doesn't make sense. You can do it, but honestly, the overhead is bigger than the benefit you will get. But on table like this,
so for lots of reads with millions of rows, it's probably a good idea.
Yes, especially if you need to read and aggregate data. If you need to access like a singleton lookup, basically what we need to do is to rebuild the row because all the row has been split in all the single columns, right? So again, there is this overhead.
Yep.
Yeah, but that's pretty interesting. What happened behind the scene, and so other interesting stuff. Oh, this is I think this is my favorite, of course. So for example, another nice and interesting technique is to store JSON in Azure SQL, and which, by the way, you can even create a column store upon JSON, and it can compress quite a lot. But the idea is that this is mainly to respond to the need of be very flexible and very agile, as we were discussing at the beginning, in terms of data model. So something we notice is that especially new developers, when they start create application, and this is I would say also true for me, it's not always immediately clear how my data model should be, right? So 10 years ago, when I was starting creating an application, it was like, okay, stop everyone, let's start to think about the data model. And unless we have a complete data model, we don't even start working, right? Well, that's not, I think this is not.
And you got to print it out on a huge piece of poster-sized paper too.
Yeah.
With the plotters, right.
Yes.
I don't think that's the world where we live anymore. Things have changed. So what I do now is usually I start to think, first of all, on my API, which kind of data they will exchange, which entities I need to, manipulate in my service. And I will start, with some very light upfront design, saying, okay, of course, I need to store a person information. It will have first name, last name, usual stuff. So we'll create my POCO object probably. And then I need to decide what to do. Should I create a table that maps to the column, or I just want to dump, the serialized version of my class somewhere? Now, if I choose the second option, I can, of course, immediately one may think to document database. Again, it's perfectly fine. But if I look a little bit more far away than my next need for the next 2 months, it's very likely that at some point I will need to aggregate data, that I will need to run some analysis, that I will need to, import data from other system and do some more complex query than just select from where ID equal 1, 2, 3, right? So it would be great if I could store the JSON document in more generalistic database, but still be able to use it as JSON or as something else like a table if I need to. And for example, with Azure SQL, you can do that because you have, so if you take this JSON, you can turn it into this table just using OpenJSON. Or if you want to have, let's say, someone has created a table, and as a developer, I would rather prefer to receive a JSON that I can just deserialize instead of having a table that I have to read and columns, horrible stuff. So I can just do for JSON. So I will do select my table for JSON, and this table will be exactly returned as JSON, which means that as a developer, my life becomes much, much, much simpler, because in literally 3 lines of code, I can do what otherwise I would need to do in, with much more line of code.
So we had a question come in, which I was actually thinking myself, which is the flexible schema of JSON. So what happens if there's a new document added with a new column or even a different schema altogether?
Very good question. So let's go here. Let's discuss about, where is that? Here. Dynamic, basically, we are asking about how do we handle a dynamic schema that I totally don't know, right? So I think the discussion is a little bit bigger than just how to handle the schema. The discussion for me, at least, and I would love to hear your feedback, is where do I want to handle the schema? Because there is a schema somewhere. It could be my POCO object or my POJO object or whatever, or I just handle pure JSON in my code. I don't serialize and deserialize anything. I just deal with JSON in a like, for example, what I could do with Python. I just deal with JSON or Node, and then I rely on the database to actually store the schema. I make sure that if I need a first name, I have a first name, right? Or something in between, like a hybrid solution. So I have prepared an example to answer that question that is already available. I just have to finish up the documentation, but it shows how you can actually create, I don't know if you know this website. I love this website, To Do MVC. And so what I did is create basically the backend for the to-do, and the backend is provided by the specifics requirements defined here. And one of the tests that you have to write and make sure it's green before you deploy and have your backend working with the to-do MVC is that they ask you to implement everything, and then they add, without telling you anything, a new property. How do you deal with that? So if you have JSON, that's easy. You just create the new property in your POCO object. The JSON is stored as JSON in Azure SQL, and that's it. You just return it and that's done. If you have preferred to add a new, to turn the JSON into a table, it's very easy. You just add a new column. You do literally alter table, add column. And since you want this column to be nullable, right? Because all the previous to-do, in my case, were stored without that new property, of course, you need to support the null. Now, if you create a column that is nullable, it's actually a metadata operation. So even if you have 1 billion rows, it will always take 1 millisecond because we are not going, back in the previous data and updating the rows. So this makes the ability to change the schema quite easy. And let's see here. Oh, here we go. This is the sample I was describing. And if you go to the database, so this is the example. For example, adding, here we go. Yeah, that's all you have to do. And then my storage procedure.
Can you zoom a little bit?
Oh, yep.
Your font. Perfect.
And of course, after I have done that, the only thing I have to do in order to make sure that let's say in this case, I use the storage procedure, my storage procedure sends data out correctly is just add the order here, and that's it. Then I just do for JSON, as said, and this table will actually be returned as JSON. If I saved all this stuff as a JSON document, of course, I don't even have to do that because the order is implicitly, so the order was the new property added was implicitly contained in the JSON. So the only thing I have to do is decide on the application if I want to deserialize the JSON into an object or not, basically. And this is exactly.
So can we go back to Can you go back to your slide?
The slide? Yep.
Yeah. So it's interesting looking at this because I was actually discussing with a couple of people yesterday something very similar to this when it comes to using Entity Framework to map to different databases. In the sense that we have the Cosmos provider for EF Core, that is basically doing document database, all the way down, and then we have the SQL Server provider or any of the relational providers. SQL Server provider, we're adding support to query into JSON columns in EF Core 6. That support already exists in the Postgres and MySQL providers, so we're bringing it to SQL Server. And so then where you place that separation, where you say this is well defined in a schema and mapped to specific elements of the database, whether that be different document collections or whether that be tables, columns, or whatever, and where you stop doing that and say, okay, from this point onwards, it really is dynamic, and I actually just want JSON in here that can change, and I can handle very very dynamically. Figuring out where to put that line is quite interesting, and I think for our Cosmos provider, it's interesting to look at where we should kind of split these things and map these things, and where we should just say that's JSON and it's just JSON and we're not really doing anything with it, and I think Jeremy has been investigating some similar things, looking at putting to sample together with Cosmos as well. So figuring out where to do that split is I think a very interesting question, even across all these different technologies.
Yes.
So anyway, that was my comment.
No, I agree. And in fact, that's why here, for example, you can see, so I have this tree controller. If you go to the hybrid, basically, you will see, and actually the table shows it a little bit in an easier way. If you go to the hybrid, that's what I did. Basically, all the properties I know will be there for sure, I will map to columns. Everything else is in the extension, which is, now we don't have right now a JSON data type. We just treat JSON as it is, like a string. So this will just contain JSON. And the only thing I have to do if I want to rebuild the full object is just merge the produced JSON, querying this 3 column, this one, and then it's done. This, in my opinion, is one of the most flexible option you have.
So what you lose there, though, is any indexing over your extension properties, correct?
Correct. But you can actually create a, let's see here. You can actually, let's see if I have, it's here or somewhere else. No, I think it's test. So you have the option to create an index over JSON. Let's see if I can show it to you. I prepared nope. So let's say, okay, probably is here somewhere, I guess. Oh, maybe in the miscellaneous folder. Let me see. But basically, you can create a new column that extract the value you are interested in from the JSON, because you have a function called JSON value that you can say, okay, I want to extract that, giving a JSON path, that value from JSON, and we'll put it into a column. Actually, that column doesn't exist. Is a calculated column.
Okay.
But once you create that column, you can actually index it. And the core optimizer will be clever enough to understand that even if you are searching within JSON, but the same path you are using is actually indexed by the column you have created, it can actually use the index. So it's pretty fast.
Very
yes. Cool. Oh, here we go. I think this is the sample. And let's see. The procedure. Okay, I have definitely that case somewhere. But
couple of questions coming through on the chat here. So what if you have nested columns and they have nasty names?
Oh, you can always alias the column. So when you do open JSON, for example, let me do that. So let's see. Yeah. So you see, you can always say, okay, I want to extract from the JSON, from the root. I have a column called ID, and I want to put it. I want to extract it in a column that is also named ID. But you can choose these, and these are something you can always choose. So even if you have nasty column, doesn't really matter because you can always alias them.
What is the nested? Oh, I'm sorry. Go ahead.
I was going to say, but when you do the for JSON thing, which creates JSON directly, can you do a similar thing in there to change the names of properties in the JSON compared to what?
Yeah. Okay, yeah. So let me go to another example. I have a full set of sample around JSON here. Azure, yeah, perfect. Here we go. So this is another link I provided in the URL I've sent to you, Jeremy. Yep. And here you have a lot of samples. Actually, I just noticed that I was missing the temporal sample. So before we mentioned support to temporal tables, I said, oh man, I have to add it. So I created an issue. But here you have JSON samples, and I used some feature called Notebook that is supported in Azure Data Studio. And the nice thing is that you can, for example, wait for the notebook to load. And so we can actually see the query and the result together here. So for example, let's see, you want to extract some data, right? So you want to extract some value from JSON. You can do open JSON and specify the children. Of course, then you can even decide to specify a schema. So let's say that you want to extract from a nested property called state within address, but you only want to call it state. So the result of this open JSON will be something like that.
Very cool.
And of course, also the opposite is true. So you can create JSON, and with the close, where is that? For JSON path, let me pick it up. Here we go. You can say, okay, I want to extract data from my table, but I want to put is alive in age under the additional info object within JSON. So you can even create a nested JSON. Now, with JSON path, you have to do it yourself. If you use JSON Auto and you join users with another table, we use the join clause to understand there is a relationship. And so we actually nest the address, for example, under the user for you automatically.
So there's a great question about array values. Can you aggregate them, or how is it even handled if you have a property that's an array?
Can you aggregate values? That's interesting. Not sure was.
So the question would be like, could I store a property in my JSON document that is an array?
Yeah,
and then
sure.
if I did, is there a way when I extract it, let's say it's a sequence of numbers, could I aggregate or collapse? Or
yeah, absolutely. So let's say, for example, I think I have an example here in OpenJSON query. And this is the easiest way. This is how, for example, you can pass arrays of data to a storage procedure. Actually, we can also do it live if needed. Let's do it live. So let me zoom this a bit. Let's say like that. So let's say we have a JSON like max equal, and let's say we have an array of values, right? So let's start the easy way. We have an array of values. I can do select from OpenJSON, and I just come on J. Okay. And I just want to have the value, of course, to go. So basically,
and so you would do a similar select down to if that was a property on an object. So let's say you had foo, and it had a property,
foo, and then you have something like that, right?
Yeah.
Yeah. So I would do, where is foo? Foo is in the root of my, and that's it.
Boom. Wow.
Yeah.
This is not the SQL I used to work with.
No, right. It's very different. And again, for example, this stuff, let's say you have a graph now. You can use JSON to add a column in your graph table so that you can literally have the same behavior of a graph database. We even support the match clause. We support the Cypher as a language, which is very similar to what you write with a Node4j. So we really tried hard to make sure that whatever is the need you have, you can find it in Azure SQL. Now, we don't want to excel and be, the super specialized GraphQL database again. Graph database, sorry. But what we want to do is make sure that if you have a generic need, you don't necessarily have to go somewhere else to find. Maybe you still want to, because there are some features that we don't provide yet. But if you have let's say an average need, probably Azure SQL provides all you need already for you, without you to have to deal with data integration, which again, in my opinion, is the most painful thing you can ask to anyone to do. It's so difficult. So for example, we even are able, using the memory optimized table, to implement a key value store pretty performant. But and we have spatial support. So there is a very nice sample that shows how you can actually capture real-time data of buses going around in Seattle, save it into Azure SQL, and ask if a bus is within a geofence, which is basically a polygon, and send a notification to you when the bus is close to your geofence. This is what I was using, not to miss the bus every time I was working in Building 44. So it's again, everything is inside. And since I saw someone mentioning scalability, and before I just saw the word scale in the comments. So one of the things that we really worked hard is basically re-architecting and refactoring completely SQL. Now, by all means, if you have tried Azure SQL Hyperscale, it's just the SQL engine. Is T-SQL is actually the same engine. It's not. I was saying it behaves. No, it's really the same engine. What we changed completely is the storage behind the scene. So with hyperscale, what we do is that we don't store the data in files anymore. Well, we still do for durability reasons, but mainly your data reside in servers, in services. This is a hugely distributed service. So the page server is the server that actually contains the data. And each page server contains 128 gigabytes of data. When you reach that size, we add more page server. We can arrive to handle 100 terabytes of data with this architecture, because we just add the servers, right? And servers come with memory and CPU. So we also literally add more resources. Now, since the data is completely detached from the compute node, the moment you want to create a replica, we just need to spin up a new compute node and connect that compute node exactly to the same set of services that provides data, right? So this means that in something usually around 45 seconds, we can spin up a new compute node and provide the read-only access to all your data. So this helps. So we are not doing any multi-master thing at the moment, but this helps a lot when you have a typical OLTP scenario where you have a few writes, but a huge amount of reads, huge amount. And you want to scale up, to scale out these guys as fast as possible and as much as possible in order to handle all the incoming traffic, right? And since every write done here is immediately written in the page server, and these guys read from the page server, basically the latency is almost none, because we are physically not copying data around. We are just serving the same data. Today, you can have up to 4 readable replicas, and which means you can go up to 400 processor in total, which is still a decent number. In future, we want to relax this limit so that you can go even higher. We did test running with 1,000 processor and more. So if you are creating some online game or some streaming service, that's perfectly suitable for you, or even doing HTAP. So just to answer one of the comments I saw around scaling, and
so we've got several people asking a few questions. So let's take a few of those. I think actually I'm going to go right back up to the top from a long time ago, where, if I can find it, where Eric EJ asked something. Here we go.
Oh yeah.
Yeah. Any plans for AAD only security?
I think we already released it. I just have the announcement. I'm pretty sure. Let me quickly find it. Here we go. And here we go. This one. Azure Active Directory only authentication for Azure SQL.
Okay,
that's a great answer.
Yeah.
Good. Yeah.
And then we've been talking about Azure SQL. The question here, I don't know if you'll be able to see it all, but the question is basically, if I can't use Azure SQL because I have to do on-premises for my customer, what am I missing? Are all these features available, on premise as well?
Yes. So all the features I described briefly and many more are always available in both, where the architecture makes sense. So, for example, this huge scalability we have with hyperscale is not something we can do on-prem. But from an engine perspective, all the features are available. Yes, are available in all our SKUs. So from edge to the cloud. So column store, in memory, graph, geospatial, JSON support are all available today already in SQL Server.
I think we've done a couple of sessions with Eric EJ on DAC packs and using those. And one of the great things about that approach is that you can basically run your testing against local SQL Server with all these features in it, even though you're going to deploy to Azure and have it actually run in Azure. So yeah, that works quite well.
Yes.
Next question. Can you integrate Azure SQL with Azure Search?
So two answers here. So we still have the full text search, which many customers find it pretty useful because it's deeply integrated in the engine. So if you don't need the full extent of Azure search, full text search is usually more than enough. But if you do, we already have integration with Azure search. So Azure search is actually using a feature called change tracking that allows anyone to ask Azure SQL or SQL Server what are the changes that happened between the last time I connected and now that I'm connecting again. So Azure Cognitive Search actually is using change tracking to make sure all the data is actually sent to the search engine in a very efficient way. Yeah.
Sounds good. And let's see, how about this one more question? This one. CAP theorem using key value store in SQL Server.
No.
I don't know what that means, but there you go.
The CAP theorem is a guess that you have. You can only have consistency, availability, or P.
That's right. I remember now. Yes. P. What's the other one? Anyway,
I would say partitioning, but I don't remember. But anyway, basically, it's eventual consistency. Partition, right? Yeah.
Yes.
So it's eventual consistency. We don't do eventual consistency at the moment. So when, for example, when you use a key value store, if you want to create a memory optimized table like this one, here you go. Everything is consistent in the sense that your transaction and Jeremy transaction, for example, can see two different values, but all consistent where their point in time. That's how the versioning works. So as long as my vision of the world doesn't change, as it's consistent, I am fine. And this allows others to move, in future compared to where I am at the moment. It's a pretty complex stuff, but it's amazing how it solved the problem with lock, just completely creating a relative, vision of the data still consistent. So, yeah, we don't do the CAP theory at the moment.
Okay, cool. I think those were the questions we had right now. We have a few minutes left. I don't know if there's something you want to end with.
Yeah. I just want to share that we did a lot of work creating samples lately. Oh, this is also my favorite. How to deploy a database with a full CI/CD pipeline, test included. So just want to be honest, there are no unit test framework. There is only one, TSQL-T, but it's not applicable, unfortunately, to Azure SQL at the moment because it requires .NET Core running in Azure SQL, and for a security reason, we don't allow to do that. But I'm really a fan of unit testing. So I just use the NUnit, which is a kind of a workaround, it still works decently, to make sure that every time I test, I deploy something. After I've deployed my backpack, I also run tests to make sure that, for example, storage procedure runs and has, the value expected given the input value and this kind of stuff. So this is also doable from, for example, GitHub Actions, because we have specific action for deploying database. But if you go to code samples, so docs.microsoft.com, and then click on code samples and search for Azure, and then go to Azure SQL, to SQL database. And here you have 29 results from the basics to the most complex one, like a complete to-do MVC backend, real-time serverless geospatial transportation geofencing solution, other one using Node.js with Azure SQL, change tracking we were mentioning before, row-level security. So we tried really hard to make sure that the most common languages that today I would say are Python, C#, and Node are well covered, and you have a end-to-end solution that you can deploy that use or web apps or functions and Azure SQL behind the scenes, so you can literally have a working example and see how that can be done. I'm also starting to create some of the applications specifically with Entity EF Core that I was not a user recently. because again, I'm a SQL guy, so I really want to write my SQL. But after seeing the latest session you had on EF core performance, I really wanted to say, okay, this, as you said, this is not the EF I learned many years ago. Is way improved, so it's better for me to refresh my knowledge and catch up. So yes,
excellent.
And last one, just some self-promotion. We wrote this book has been written all by members of the Azure SQL team, and this is cool. Really specifically taught for people who never used SQL Server before. Because if I'm a new developer and I'm lucky enough to just use the cloud, I literally don't know what SQL Server is, right? And honestly, I don't even have to install it, luckily for me. So this starts from, understanding what Azure SQL is, the different option, and starting from the basic up to everything we discussed today. So graph, index optimization, of course, storage procedure views, and I think it's a great book. I mean, of course, but it's something I would love to have if I would have been a new developer.
Sounds good.
Yep.
Okay, so I don't know, Jeremy, do you have anything else? Looks like we're out of questions on the chats there, so
I think we're good to go. That was super exciting. I knew that a lot of changes had come through on Azure SQL and SQL Server, but this was a great overview, especially thinking about some of the support that shouldn't lead people to take on an entirely new database platform just because they need to support in a certain case a certain style of interface. So thank you for sharing that.
Absolutely. It's a pleasure.
Yes, thank you very much. And I guess that's it then. So I'm not sure what we have next week. I think Shai is on the line to do something. So in 2 weeks' time, we'll be back with whatever Shai comes up with. So hopefully we'll see you all then. Thanks,
Sounds
guys.
good. Take care, everyone.
Thank you very much. Have fun. Bye.